uh, let's understand this question. Okay, what is common between all these things? Let me write down what is common between all these things. Data is the word that is common between all these things, right? So data analysis, data mining, data science, and data which is big. I would say all of this analysis, mining, and big comes under one bracket called data science. So I'm going to put it here, and there we go. Data science consists of analysis, data mining, and big data. Okay, I'm going to write big data here. First, let's understand what big data is. Then we'll go ahead and understand what data analysis and mining is. So what happened is since 1950s, data science has always been there, because the science of data involves statistical analysis. We've been doing statistical analysis from ages. I mean, even when we were in school, we were taught about concepts like standard deviations, variance. Remember? All of this has always been there with us. But what happened as we moved away from 1950s and moved towards the 2020s, there's been a revolution in the amount of data that we've been collecting. So right now, your smartphones and your activity on internet is generating tons and tons of data. But the problem is how to analyze all of that data. When I say how to analyze, what I'm trying to mean is where do you store it? Where is it stored? Do you think your 2 TB hard disk is enough to store this much data? The amount of data that is being generated? Just Amazon alone will require acres of hard disks to store the amount of data they're collecting. Now, if the amount of data that is being collected requires so much space, imagine the computational power that is required to compute all this data. Now we can call it big data because it's huge, right? That's where big data analysis comes in. This whole idea of big data analysis is such. What happens with big data analysis is when you want to analyze this data, the question is, where is the database? The database is not just one single point. If it is just one single point, it's just one single source. What does the database contains of? Rows and columns, like your Excel sheet, rows and columns. Now, imagine if 100 GB worth of data is all arranged in rows and columns. That many rows and that many columns. All of this is totally about 100 GB. This is a very minimalistic and modest estimation that I'm giving you. And do you think one program, one computer program is enough to go into this database and fetch information for you? Would it be possible if there are 1,000 people a second who's querying, let's say, our UPI payment interface, and all of them are interacting, and their data has to be understood? Everyone is logging at the same time. Everyone is keying in their password at the same time. So if UPI or the institute which handles UPI keeps all of their data in just one database, if they start using only one program to query and fetch the information of all the 1,000 people, do you think all of these 1,000 people are going to get their result simultaneously? Impossible, right? It's impossible. It cannot happen. That is why what is done is we take this 100 GB data and distribute it across. But we distribute it across in such a way that when these 1,000 people query UPI has its own logic to ensure that each of these 1,000 people feel that they're all being served simultaneously. But the internal logic knows where to go and fetch this data. When I say this logic knows where your info is. Now, how do you write an entire system to code the right place to look for data? This whole thing, the system to code the right place, this whole thing comes under big data analytics. Big data, not analytics, sorry, big data as an umbrella term. Now, the key concepts whenever you say there, I want to take a certification in big data, and we want to set up big data on for the enterprise. So all of that comes up with the key term that you've been always listening to. It's called map reduce. The whole idea is in map reduce. This is the map, right? This is the map of where the data is. This is a map. And system to code is nothing but reduce the effort for the algorithm to go and find this data. So this map reduce technique is where you will map out all this 100 GB data into 10 GB, and it can be distributed anywhere. Whoever's got some space, the logic is so watertight that it doesn't matter where the data is stored. This can happen even with your 10 to 15 computers rigged together in network, and you can distribute all of this data in an enterprise level. This is what it is. There's always a server which serves this data in a perfectly watertight logic. And when you take a big data certification, that you become a big data engineer, you're going to be understanding the system of coding and the idea of map reduce. And there's a particular language, which is the whole idea is built on languages which extensively use lambda calculus. It's a fancy word, but once you understand, it's a derivative of functional programming languages. So if you know basic programming, and then if you're comfortable with a little higher level of programming, recursive programming and stuff, then you'll be able to master it. And of course, as it knows, it just takes some amount of practice, and then you'll get to know it's been made very simple. And so that's what it is. That's what we say. That's what it means when we say big data. So now it's up to you to understand what is the difference. Big data is just a way to handle big data. That's what it is. Now coming to data analysis. Let's talk about data analysis. It's a big term. Data analysis is a big term. Of course, you know the meaning of the word, what analysis is. So why do you want to analyze data? The first question is, why do you require to analyze data? We want to analyze data so that we can come up with some conclusions, some hidden logic in data. So what is data? Data can be of many types. Data is numbers, symbols, all together. Numbers and symbols, they are put together to make sense to us, right? For example, data of census collection, right? Census that has been collected. What kind of data you have there? You got age data, right? You collect age, and then you got gender. Age is all numerical, right? It can be 12, 24, ... somewhere up till 100. It's got a range. And gender can be male, female, others. Or let's say others is just a big O. Okay, so these are symbols. So this kind of data is called a mixture of categorical and numerical data. Now, when you want to analyze how many males did we find between the age of 24 and 35 from all the data that has been collected for India, let's say, that's like a simple query. And you get out all this data, and a number of it calculates for you. It comes out with there are so many number of males between the range 24 and 35. If there is something else that you want, if there are some other information here, like what kind of jobs do they have and what kind of education qualification did they have and what kind of salaries they draw, there are many other data that is collected if in case the company can. Now, if you want to understand what is the relationship between the education they've had and the salary they've had and the job they've had, right? If there is there's a relationship. If you want to dig into this relationship, that's what analysis is. So for this analysis, we rely largely on statistics. And if you use machine learning algorithms to predict it, it becomes predictive analytics. If you simply want to analyze what is the relationship, you get a relationship. But if you want to use that relationship and model that relationship as in a machine learning algorithm, you can after that, you can start predicting what kind of salary a person between 24 and 35 with a certain education and a job might be drawing, right? This might be drawing is what prediction is. So that's what that is predictive analytics. This is data analysis, that is predictive analytics, right? And data mining. So mining the data. What is mining the data? What we did right now is also sort of mining data itself, but data mining is under a broad category. For example, let's say we know that Flipkart keeps asking us for feedback on all different kinds of products. So what is the feedback? How does it look? Symbols, right? We've got symbols. Symbols are your stars that you give, right? And you have some sentences. So sentences can be your normal sentences, but there are certain keywords. Keywords like good, bad, excellent, right? So when you want to mine the data to understand on an average what kind of feedback did a particular product X receive, when you want to mine that, you will require not just statistics, you also need to know how to understand language. And what language is this? This is natural language. Our natural language, our English, right, is a natural language. So this is natural language processing. So this is one of the key fields. You process, it's called NLP, natural language processing. And this is a domain in itself. People get PhDs, people make a career, people have written tons and tons of paper, research, document, and somebody who understands NLP and understands statistics and understand machine learning and understand data mining principles, they become experts at mining such data. So this is just one of the examples of mining data. Mining data could also be not just about NLP, but it could also be about mining share market data. So it can be about mining health data. So what are we looking at? Data mining is not just an engineer's job. Data mining requires engineering. Engineering, when I say IT, computer science, programming stuff, plus domain knowledge. What are the domain knowledge I'm talking about? Domains like good with languages. You either know share market very well, you either know health informatics very well. So each of these domain people, when they get certified on stats and NLP and big data and programming and all of this, then they become data mining experts, executives, data mining professionals for a particular domain. They don't, whoever is good at health informatics cannot go and do it for share market. They can help them as a side, as a support, because the techniques are same, but no way they can qualify to evaluate the results, because evaluation is the key important. What have you mined? Did you mine something properly or not? Who's going to evaluate? Only the domain specialist can evaluate. So data mining is about mining, but it is supposed to be done by the domain experts. So I hope there is some clarity, and if you want more clarity, then you can always write back to us at learn@analogica.in. Thank you.